Okay, so today, just gonna move it back a bit. Today I'm going to, I just gave you work time and I think I'm just gonna go with the unit review. There are a lot of questions. I don't think any of the concepts in probability were super hard, but the concepts seem to really get a bit confusing for students because historically the students haven't done that well in this unit, either in our unit tests or in the final exam that the province puts out. So of course we're not having to worry about the final exam this year, but still, just due to past experience, I know that students do struggle with this unit. So I'm going to go over the questions for Unit 6 review. So if you had any problems at all, that will hopefully clear up any confusion you might have had and prepare you to write the test for this unit. So I'm not going to give you breaks to work today because I'm assuming that you used your time yesterday to work through. So here we go. We're going to start with number 1. This is lesson 6, probability. And I'm just going to work on paper like this so I can work more freely. Not to say review of probability, because that's what we're doing here. So there's the concept of probability, what probability represents, why we use it, I guess. And to use it, we're just making more more sense of what's going on around us, right? And especially for decisions that we have to make, whether or not the decisions involve financial stakes or not, but probability appears in all aspects of our life, certainly the weather, right? That's why we're inundated with probabilities. So let's take a look. We're going to do number 1. This is just standard definition of probability. There are 20 jelly beans in a jar, 12 are red, state probability of red. So probability of red equals, well, 12 are red, so 12 out of 20, right? 12 out of 20 are red. And that's it. Probability can be expressed as a fraction, a decimal percent. If they don't tell me how to express it in any special way, I'm just going to leave it as a fraction. It's just easier. So if they tell me that 12 are red, that means 8 are not red. 8 and 12 are complements of each other because in total, they add up to the total amount of jelly beans. Probability of blue, well, since there are no blue jelly beans, right? 0 out of 20 or just 0, right? Either one's acceptable. All right, let's keep going. Number 2. So number 2, there are 450 students in a school. 100 are in grade 12, 120 in grade 11, and the rest in grade 10. How many students are in grade 10? Okay, so I guess we have 450 in total, right? We take away the grade 12s. We take away the grade 11s. So that leaves us with 230 are in grade 10. All right. If a student is selected at random, find the probability they're in grade 10. This is just the number of students in grade 10. So probability of just randomly selecting a grade 10 student, I have the number of grade 10 students over the total number of students. Determine the probability the student is not in grade 11. So probability of not in grade 11, just reading your comment. Is it also acceptable to put not enough info? We are not told whether there are any. Oh, that's true, right? That is true, right? That's a very good point. Or not enough info. It's probably a better answer, Cynthia. Yeah, you know what? I just assumed because I wasn't given any info on blue, they weren't blue, but you're right. That's probably a better answer. It's kind of a weird question. Determine the probability in not grade 11. So probability not in grade 11? Well, that obviously means they must be in grade 12, right? Or 10 or 12? They must be in grade 12 or 10. Okay, so I had 230 in grade 10, 100 in grade 12, right? So that's going to be 230 and 1, 330 out of 450. Or you could have just taken the 450 and subtracted out the 120. 2B is grade 12, not grade 10. Oh my gosh. Thank you, Cynthia. Oh, brother. How am I reading this? Probability in grade 12 is 100. It's a good thing I've got someone watching me. That would be 100. Agreed. Thank you. You're not being critical. You're being a good editor, because otherwise I really appreciate that, because otherwise people will be confused when they watch it later. I have a lot of people watching later who can't watch in real time. So I appreciate that, Cynthia. I'm going to try not to make any errors. Yeah, but that you're not being critical. You're being correct. Okay, did I get this one right? Not in grade 11 means I'm going to take my 450, take out my 120. I'm just going to double check that. 450, take away 120. Perfect. Okay. Number 3. Can you still see me writing? No. Okay, so I'm going to remove my questions, and please just look along. And if you're looking at home or doing this later, just keep looking at number 6. Look at your answers. Hopefully you've already tried these already. And you can look at the questions that I'm referencing. A game is played where a coin is tossed. If it lands heads, you are given $10. If it lands tails, you're given $5. Find out the expected value. Okay, so they jump right to expected value. Okay, so there's in this game, I'm just gonna show you again. In this game, there's 2 ways of winning, right? There's 2 amounts you can win. So you have 2 probabilities of winning, 2 ways to win. If it lands heads, you're given $10. If it lands tails, you have to pay $5. So that's the cost of the game. So let's see, calculate the expected value of the situation. So once again, expected value is probability of winning. So I guess probability of heads, right? Of getting a heads times the amount won, which is $10. If it lands tails, you have to pay $5. And then minus the cost to play, right? This is a little confusing for me even. So let's just do this. Expected value equals probability of heads, which is 1/2, times $10. Okay, so that's the probability of heads. And I guess now I have to figure out if it lands tails, right? This is the cost. If it lands probability of tails. So we're going to do this again. Okay. This is the probability of heads. This is the probability of tails. Now, if it lands tails, because it's either this situation or this situation, if it lands tails, I am going to have to pay $5. Whoops, what am I doing here? So that's going to be a negative $5, right? So that would be the cost of my game. If only correcting wording and stealing is a career path. You know what, Cynthia, I'm going to get back to, because there is a career. It's called a word editor. So cost of play is whatever you, I think this is this is the only way I'm going to get a negative amount, right? the cost to play is if it lands tails, right? I think it's a very confusing expected value. So I have, this will be $5 minus $2.50, so it's going to be $2.50. It's a very confusing one. Do you think this is a game you should continue to play? Yes, because the expected value is positive, right? So that means you're in a win situation. Or I would, right? If you play this game 100 times, I mean, other answers are possible. You could say no. You could say no, there's no guarantee. We're just doing expected value, but there is no guarantee that you're going to make that amount. So if he wins $250 each game, if he plays 100 games, he's going to win. What is it with me and my double symbols today? $250. Guess so. Okay. Yeah, and in this case, I guess you're always looking for cost to play is going to be a subtract amount, right? Or amount you subtract. So in this way, in this game, he loses money if it's tails, so that is the cost to play. Because he only has to pay if it lands tails. So that's what the cost would be. Number 4. Okay, we move up. Number 4. A spinner has 6 equally sized segments. Each segment is a different color: red, orange, yellow, blue, green, purple. You spin the spinner once. I'm going to see if I can fit the spinner up here over my work. You can barely see it, right? I'll move down a little bit. So here's the spinner. If the color that you spin is yellow or green, you win $20. If the color that you spin is not yellow or green, you lose 10. So I'm going to just do a little bit of, so I'm going to say, let's see, color that you spin is yellow or green. So if you spin yellow or green, that means you get $20. If you spin any other color, you lose 10. So I'm just going to say then the probability of winning, if I look at it this way, is 2 out of 1, 2, 3, 4, 5, 6. 2 out of 6. Probability of losing then is 4 out of 6, right? And I can win $20 or I pay 10. Okay. So that's how we do this one. So expected value, this is what I need for my formula. The probability of winning, which is 2 out of 6. And how much do I win? I win $20. Okay, so that's and then the cost to play, well, the cost to play is $10, right? But the cost to play, or the probability of, I'm going to do this one like, because there's more than one, these ones are a little complicated, right? Because there's more than one way to lose. 2 divided 6 times 20 minus 4 divided 6 times 10. Yeah, we get $0. Because there's more than one way that you would have to pay the $10. I know it's a little confusing, but it's similar to how we did number 3. So sorry if that confuses you, but I hope that's a little more understandable here, what I did there. You can always ask me questions later if you need to through email. Okay, now I just need to find my other page, page 25. There it is. Okay, page 25, number 5. I'm just going to flip to a new page. Okay, number 5. Jack is considering buying stock in a new company that manufactures exercise equipment. He's thinking of investing $500. If things go well, he could make a profit of $2,000. If things go bad, he could lose all of his investments. There's a 40% chance that things will go well. Okay, so this is regarded things going well. That's the probability, or that's the probability of winning, right? So the probability of winning would be 40 out of 100 or 0.40. All right, calculate the expected value. So the expected value equals the probability of winning, 0.40, or 40 over 100 if you prefer working in fractions, times the profit, which is $2,000, minus the cost. Here, there's just a straight cut cost, right? There's a one-time cost. So there's no various ways to lose money. So 0.4 times 2,000. So that's $300. Is the expected value you calculated guaranteed? No. There is no guarantee. Things will go well. I mean, we just learned in the last few months, right? Even if you plan something really huge and big, it all could have just disappeared in a moment with the COVID crisis, right? That just shows you how random life can be, even if you think you know what's going to happen. I mean, no one ever anticipated we'd be finishing school with remote learning, right? Okay, let's try number 6. On a big table, there are 12 covered plates. That means you can't see what's on the plate. Each plate has food on it. 3 plates have steak, 5 have fish, 3 have mac and cheese, and 1 has chocolate cake. If you pick a plate at random and lift the cover, state the odds. Okay, so be careful. This one asks for odds. So, whoops. That means it's easy to miss that word, but they want odds and not probability. So this is odds, this is odds. Okay, I'm going to just highlight that because you can get kind of just caught up in doing probability. Okay, I'll go back and do that one again. Let's see. The answer key says $500. Let's see if I did something right or wrong. He's thinking of investing $500. He could make a profit of $200. $1,500 times 0.4 minus 500. No. What did you get, Cynthia, as an answer? Did you get 300 as well? Okay, that's his cost. He could make 2,000. 0.40. Yeah, I still keep getting 300. I think the answer in the back is wrong. I think it's got to be 300. Yeah, I agree. I think there's a wrong answer in the answer key. Okay. All right, 6A. On a table, so the odds of picking chocolate cake. So the odds of picking chocolate cake, remember how we do this? We got the number of chocolate cake, number of plates with chocolate cake compared to the number without chocolate cake. That's how you got to look at these. So all you do is count up how many plates have chocolate cake on it, 1, and then count how many plates don't have chocolate cake, and that's the other 11, right? So it would be 1 to 11. Yeah, no, I think the answer to 5A has to be $300. I think there's a misprint. Okay, let's do part B. The odds of picking fish. Okay, how many have fish? 5 plates have fish. That means 7 don't, right? And the reason I could do that quickly is it says there's 12 plates in total. Part C, the probability. Okay, now notice they flipped to probability. So train your eyes to notice when they flip-flop back and forth. So I just underlined the probability. The probability of picking steak. And I always record my answers for probability using the capital B and whatever I'm looking for. So therefore, that also kind of nudges my brain into saying, okay, I have to answer like in fraction form, right? So how many have steak? 3 plates have steak. There's 12 altogether. Okay, 3 12ths. Part D, probability of picking steak or fish. Once again, they're just asking for probability. So I'm going to do my capital P, steak or fish. Okay, 3 have steak, 5 have fish, 8 out of 12. Finally, E, I'm back to odds. Notice how they flip back and forth. The odds for picking steak. So 3 plates have steak and 9 do not have steak. And I think the answer key is, the odds against picking steak, okay? So odds against picking steak, you put all the plates without steak compared to all the ones with steak. Okay, so you just reverse it. Thought there was another wrong answer. Okay, so not hard. You just have to pay attention to what they're looking for, right? Are they looking for odds or are they looking for probability? Let's take a look at number 7. The probability of seeing the northern lights is 3 out of 10. State the odds in favor of seeing the northern lights. So probability of seeing the northern lights, 3 out of 10. There's 3 nights, I guess, you can see the lights compared to 7 where you can't. State the odds against. Well, it's just flipping it back, 7 to 3. Number 8, the probability the Jets beat the Blackhawks is 25%. Odds in favor of beating, so 25 to 75. Remember the 2 parts of probability of the odds make the whole of the pool of whatever you're looking for. So 25% and 75% total up to 100%. Odds against would just be the reverse. Number 9. Okay, another Jets. The odds the Jets will win their next game are 6 to 5. State the probability they will win. Probability of a win then. 6 would be my numerator and 11 is my denominator. Then number 10. In a school, 384 students. The probability that a random student is going to post-secondary is 0.63. Calculate how many students are expected to attend post-secondary. So 0.63, 63% of, which means multiply 384, is going to give me, excuse me, 241.92. So you can round down or up. I think when I'm talking about people, I usually round down because I don't quite have 242 people. So I'm going to say 241 students Now I know the back of the book rounded up. Either one's acceptable. Either rounding up or down for people is acceptable. But you can't leave this as your final answer because you're talking about people, okay? 11A, a technology company has determined that the theoretical probability of a tablet being defective is 0.014. In a sample of 7,500 tablets, 80 were found to be defective. State the experimental probability of a tablet from this company being defective. To 3 decimals, state the experimental probability. Well, the experimental probability, what actually happened of a defect, the tablet being defective. Well, what actually happened? Well, 80 out of the 7,500 were defective, right? Now, it says to 3 decimals. So I'm actually going to proceed and do the decimals. So 80 divided by, that bar means divided by. So I get this as an answer. Okay, 1, 2, 3 decimals. So that would round to 0.011. So 0.011 is the experimental probability. Okay, state the odds against a tablet being defective. Okay, the odds against the tablet being defective, well, let's see. If I have 7,500 in total, and they want the number that aren't defective first, so take away 80, and I get 7,420. So 7,420 were not defective compared to 80 that were. And finally, state the number of tablets from the 7,500 sample that can be expected to be defective based on the theoretical probability. So the theoretical probability of a defect, remember what they gave us? They said the theoretical probability is 0.014 equals 0.014. Okay, remember that. So my answer would be 0.014 times the 7,500. Okay, so this is what the company, this is how many the company is saying should be defective. $105. Tablets expected to be so what do we say about that? 105 tablets are expected to be defective. In actuality, only 80 were defective. So I would say that this company is actually doing, pretty good, right? For quality, for standards, because 25 tablets, in addition to the 80, 25 more tablets were supposed to be defective according to their tests. So actually they're doing quite well. All right, hopefully I didn't go through that too fast and you understood what I was talking about. Are there any other questions at all? Let me know when you're ready, and maybe you're ready later today. Let me know when you want to write the probability test. And then we've got one more unit to go. I think we only have a week and a bit, like these tomorrow, Friday, and then next week. But I think we could get most of precision measurement done. And then we're done the course because classes are over on the 12th. And then we'll be able to get final marks in for you all. Remember that whatever you got on the 20th of March, whatever your mark was, you can't go lower than that. You could just go higher. So hopefully that rounds up your probability. And let me know if you have any other questions, like I said today, and then if not, I will see you tomorrow. Oh, you're ready for it? Okay, I'll email it right away.